off with similar polygons, so essentially dilation. So just kind of a refresher. In the beginning of the entire year, we did transformations. We talked about translations, reflections, rotations, all of that. Those all go with an isometry, meaning it maintains its congruency throughout. That's isometry. What we're looking at today for similar figures is a dilation, so not isometry. It's a dilation where it is maintaining that same shape, but not the same size, so enlarging and reducing. We're not doing anything on a coordinate plane. So we did do dilations that were on a coordinate plane before. We are not doing that with this section. We are looking at just two figures in general. So similar polygons have corresponding angles that are congruent and then sides that are proportional. Angles are congruent, sides are proportional. So when we look at these two figures, that red and the blue one, the corresponding angles, so it's going to come back similar to what we talked about congruent figures and triangles. The order matters. So when it has a similarity statement, this little like squiggle means similar. So when you have this similarity statement, it's going in that specific order, meaning angle A has to be congruent to angle E, angle B is congruent to angle F, angle C is congruent to angle G, and angle D is congruent to angle H. Okay. This here is called the similarity statement. So if I ask you, like, give me a similarity statement, that's what I'm looking for. If I ask you to just tell me the corresponding angles, this is what I'm looking for right here. And then if I ask you for the ratios of the corresponding sides, so using the actual sides, it is now a ratio. We're going to turn it into a large set proportion. So AB would be over EF, because that's the corresponding side on the other one. And then equal to BC, NFG, GH, nope, CD and G, CD, GH, and then DA, and then HE. So if I ask you for the ratios of their corresponding sides, something like that is what I'm looking for. So directions, that's something to keep in mind. Once again, similar polygons means that they have the same shape but not necessarily the same size. Congruent means they have the same shape and the same size. So something to think about with always, sometimes, never. Congruent is also similar. Anything that is congruent is also considered similar because it follows the same shape and it just happens to also be the same size. Yeah, it could, potentially. So that's just something to think about. That similar is always considered congruent, but congruent is, or sorry, yeah, congruent is always similar. Similar is sometimes congruent. Things like that. All right. So that's what this is saying. Congruent figures are also considered similar. It's just that they have a scale factor of 1 to 1. Scale factor is whatever you're multiplying by to get from one figure to the other. Which is what we're looking at here. No, we're not yet. So on our two figures, it gives you your similarity statement, so you know all of the sides that are corresponding. First thing, list all the congruent angles. So we have angle A would be congruent to what other angle? X. Angle B congruent to Y, and angle C is congruent to angle D. Okay, next thing. It says that they're similar, but if I'm asking you to check or prove that they're similar, what I'm looking for is that every single corresponding side has the same proportion, or that same ratio, excuse me. So if we look at those sides, it should be that these are corresponding, these are corresponding sides, and then these are corresponding sides. So when you turn those into ratios, they should all be creating the same simplified ratio. So if we have 35 over 25, 28 over 20, and then 42 over 30, do those all simplify to be the same thing? What do they all simplify to become? So since they all equal 7 over 5, yes, that's proving our similar figure. Wonderful. If I'm ever asking you to prove it, you have to make sure you do all of the sides that are showing, not just like one set or two sets. Now, if it's a rectangle and you know it's a rectangle, yes, you only need to do like the length and the width, because you should have enough markings to know it's a rectangle. But if it's a triangle like this, where you don't have certain markings, you have to alter. Okay, and then for writing your ratios of the corresponding side length as a proportionality statement, so that is saying that I want you to write those corresponding sides. So AB over XY, BC over YZ, and CA over ZX. I think the biggest potential trick for this is that you might not read the or like that similarity statement, and you'll go based on the picture. Like, just pay attention to if the one of the triangles is rotated a little bit, so you have to like can't just rely on like, hey, look in the same spot. So just be careful. All right. So when it comes to a scale factor, sometimes I just ask for a regular scale factor with no wording after it. I just say, what's the scale factor? And we're done. You can figure it out. It's what we go from one to the other. If I give you a specific way to tell me the scale factor, so I want the scale factor of ABC to XYZ, or saying it the other way, because that's a big thing with ratios. When you say a ratio, the order of how you say it matters. So your scale factor, yes, it's 5 and 7 for those two relationships. Like this one is our 5, and there's our 7 when we reduce it. But depending on how I ask it, if I'm specifying like a specific scale factor, it's either 5 over 7 or 7 over 5. Two ways to figure it out. First way, when it comes to your scale factor, whenever it's listed, it'll always be the second one listed over the first. If you memorize that. The second way, which I think is just kind of like, it helps double check yourself. If it's saying we're going from ABC to XYZ, so we're going from this side over here, did you just increase or decrease? Decrease. Like it shrunk for that dilation, which means your scale factor has to be less than 1. That's how you make something reduce, less than 1. Same thing here, if you are going from XYZ the other way, that's enlarging that figure, so it has to be greater than 1 for your scale factor. Yeah, if it doesn't specify that little like which one to which, it wouldn't matter. You could give me either answer. But if it does specify, then it will mean different. Guaranteed probably half points off if you just mess up. Okay. So on to this next one. I'm going to tell you the scale factor for this one. I want you to go from the figure that has D to the figure that has F. And on this one, I want you to go from Q to Z. So Are they similar? That's your first question. If they are, what is the scale factor, and write a similarity statement. So the first one is similar. What's a similarity statement you could write for it? CWXY is similar to FJHG. Okay. That's first part. Second part, I gave you a specific way to write the scale factor. What would the scale factor be going from the Z figure to the F figure? 4 over 5. Okay. A quick way to just double check yourself, I even draw it like, okay, well, there, reduce it. I know it seems like maybe you don't, but it's just a way to like catch yourself with a little mistake. That way you're not kicking yourself when you get a quiz back. And like, oh, dang it, I could have had a 97 instead of a 94, like things like that. Okay, on number 3, are they similar? No, they're not. So, because this is half, and then looking here, that's 4 to 3, 3 to 4, whatever. So, since they are not similar, there is nothing else you write. If they are not similar, you don't give me a similarity statement because no, they're not similar, you can't. But also there's no scale factor because there's nothing consistent. So you just no, call it in. All right. Go ahead and answer these two as well. Everyone was right for this first one. You want to see wonderful. What about the menu one? They're not similar. 10 over 12, and then 6, and then 12 over 14 are not the same ratio. Uh-huh. But you don't know that they're equilateral. So it's just something. It doesn't say that they are. There's no marking. Like, if there was something like an additional marking, then yes. But it wouldn't. Even if it was, it wouldn't match with like your similarity statements wouldn't be matching. So you would still want the course, like you still want it to match up with the similarity statement. All right. Do these ones also. Yay. 5 is where you have to be careful. Like the picture is kind of rotated. So when it comes to solving for x, there's one of the many ways you write a proportion. What I have in pink. You get 55 over 2. 55 over 2. There you go. Y, there's your proportion. 12 is your answer. You got 12, just a different way. Wonderful. And then Z is just talking about an angle measure, which was corresponding with J. So 55. No work needed, 55. Okay. We're going to skip this section because it's the same as what we just did, just another way to solve. So we're going to talk about the perimeters. So when you have the perimeter of a figure, the perimeter of the figure still has that same scale factor. So when you're comparing two figures, if you have the perimeter, it still matches up with that scale factor that everything else has. It's still part of that same, it still uses that same ratio. So when it comes to solving for the perimeter of similar figures, there's a long way and there's a short way. We're going to see that. So here's our figure A, B, C, D, E, F, G, H, J, K. So A, B, C, D, E, matching with the same. So they are lined up nicely, so you don't have to think too hard. They're lined up in the right spots. First thing is finding the scale factor. What would the scale factor be? 2 over 3, good. The reason, so there's two ways to think about it. It's the second over the first, meaning pick one of your sides that has things labeled, so there. The second one is A, B, C, D, F, E, so 10 over 15, so 2 over 3. Or if you just think about it, we're going from this one to that one, so smaller number. Solve for X, that's our next step, so similar to what we did before. If we have 2/3 of our 18, since we're going from there to there, or you can set up a proportion, either or. What would the value of X be? Wonderful. Okay, that is so far. Now for the perimeter. There's a long way to get there, or there's a short way to get there. The long way. The long way would be going in and finding what those other three missing angles or sides would be, because it's asking for the perimeter of the smaller figure. Long way is using your proportion to find the missing sides. That is still a possibility. You can still do it that way. It's just, if you have a test or a quiz, you kind of want to move like at an appropriate speed. The perimeters of our two figures still fit with that ratio. So, the larger figure, all of those sides are labeled. What's the perimeter of the larger figure? Say again, Henry? Right. So it still fits, we can still set up that same proportion with the perimeter. Just like you solve for a missing side, you can still solve for that missing perimeter. This is times 23, so what's the perimeter of the smaller one? Wonderful. So you can treat the perimeter just like you would solve for a missing side. Still use that same ratio, the scale factor, whatever it is. We're still good there. Okay. So I want y'all to do number 7. This is number 7. If you feel compelled to do the second one, you can, but just work on number 7. Okay. So for the last one, we're finding the perimeter of each of our polygons. So something just to make sure you're careful with, for this picture at least, this tick mark, or like this tally mark with the 16, just applies to this specific figure, not to the VXW or VWXYZ figure. So that means this is 8, this is 6. So there are the labels. Big one's labeled. What's the perimeter of that top one? 60. Right, you can just add them all up. 50. Which then means your scale factor, if this one's 8 and this one's 6, what's your scale factor? 3 over 4, 4 over 3, whichever one you want. It doesn't say how you have to write it. So if you do 3 over 4, that would be the perimeter of the other one over 60 to be what answer? I guess I don't have it already. 45. Wonderful. Okay. Yay. Done. We'll have rest time work on homework.